Well, good afternoon. Thanks for coming out. And I guess we'll go ahead and get started. Real quick, if you don't know me, my name's Phil Polstra. I work at Bloomsburg University in Pennsylvania. And I've been using Linux for a long time, ever since I was in grad school, not studying computer stuff, studying physics actually. And one of my friends from the CS department said, "Hey, Phil, you should check out this guy's doing this PC Unix thing." And of course, that was Linus he was talking about. So I've been using Linux for a while. Used to be a software developer guy, kind of turned into a software security guy, turned into a general security guy, turned into a forensics guy. As I said, currently work at Bloomsburg University. Also known to fly planes and helicopters, teach people how to fly those things, and build aircraft, and occasionally skydive. So what's the motivation for this talk? Well, I teach a couple of classes on Linux at the university, and one day I was going through one of my classes, and we were kind of using a Python script from one of my books, and I thought to myself, hey, I wonder, could I do the same thing using just straight up bash scripting, instead of having to introduce Python, which all of my students also know because it's a required course. But I thought, let's just see how this goes. And that was kind of the motivation for this talk. So for starters, I have this script. It's just called find-files.py. And what does it do? It uses something called the magic library. Some of you might be familiar with that. So if you're not familiar with that, the magic library is essentially a library of file signatures in Python. And if you run Linux, you probably know about the file utility. And the file utility lets you say, hey, what kind of file is this really? Right? Windows machines, what do? They rely on silly things like file extensions. Linux doesn't care. Linux looks at the file and goes, oh, that's actually a Word document. Let me open that with the appropriate tool, etc. Right? So magic is an extension of that, or exporting that functionality, if you will, to Python. So it's a pretty simple script, uses the magic library, uses a couple other things like opt parse, which I use to parse command line options, regular expressions, and the OS libraries for dealing with files and stuff. Originally was written in Python 2. At the time that the book was written, they had not ported the magic library to Python 3, which has since happened. Right? Okay, so real quick, just want to give you a quick overview of this script. So like all good scripts, of course, it starts with a shebang line. It says, hey, please run Python. As I said, this script was originally Python 2, but it works on Python 2 or 3 if you install the libraries. Ports a couple libraries, magic, opt parse, regular expressions, and the OS library as well. And I defined a bunch of classes. So even though it's a small, simple script, it's actually somewhat object-oriented. So I created a class called a file finder. So the file finder is just something you say, hey, here is a sector. Here's a sector from a file. Tell me what it is using the magic library, and look for certain kinds of files. And it has two methods. It has one called matches, which says, hey, was this the kind of file you were looking for? And then file type, which says this is the kind of things that I find. And from there, I just defined a few different subclasses. For example, this one here will find JPEGs. And I use the magic library to say, get me the magic from that file. And let me search through those results and I'm going to search for some keywords that I know based on my previous experience with file and the magic library should be there, such as JPEG image. And if I find those words, I say, yep, we found your file. Otherwise, we say, sorry, didn't find your file. And then we have a file type of JPEG. And the bulk of this script is basically just doing the exact same thing for different kinds of files. Now, if you look at the main method for this script, I'm going to start by parsing some command line options. It takes a comma-separated list of file types that you're searching for. It also has a couple optimizations. You can say, this is my cluster size. So I don't go every sector. I can only go on cluster boundaries. And if you use that option, you have to give it the offset, because not all the time will the clusters align with a multiple of the cluster size. Okay, so what do I do? Basically, I parse that list of things you were searching for. This is all pretty straightforward stuff. And then I'm going to open this file. And here's sort of the main loop, if you will. I'm going to open the file, seek to the right place, read in a cluster, and keep on reading stuff. And I'm just going to say, hey, did you find the stuff you were looking for here? And keep doing that till you get to the end. Right? So that was the original Python script. So if I go back here to my presentation, you can see my first crack at this was trying to emulate this pretty closely. Going to use the file utility instead of the magic library. I'm going to create an array of items to find in the corresponding keywords that grep through. And I'm going to use DD in order to grab the correct sectors. Now, how many people are familiar with DD? Disk destroyer. Okay. So not all of you are familiar with it. DD is kind of a bit mover, if you will. You can use it to create disk images. It's pretty simple to use once you learn how to use it. If you're on a Linux box and you want to image a file system, it's pretty simple. You can say something like DD and then say in file equals, and you give it a device file, out file equals whatever you want to call your image. And there's some other flags you can get it as well, right? So ultimately it's a bit mover. Now, here's a trivia question. Since a lot of you are familiar with the disk destroyer or DD, does anyone know what was the original purpose of DD? Nope. The original purpose was to convert between ASCII and EBCDIC. That was its original purpose in life. That was what it was made for. So you can do some conversions like that as you are moving things around. But today, the way we use it is mostly just to push out our various bits and move them around. Right? Okay, so here's my first crack at this. And again, I said let's try to make it essentially the same thing. So of course, every good script begins with shebang line. And of course, I'm going to say I'm running bin bash, even though bash is the most common shell. It's not the only one that people run. And I'm going to use some extensions that only work in bash. So I define a usage function. This way, if you don't give me any command line arguments, I'm going to yell at you. I'm going to say, hey, look, here's what you should have told me. And then I go through and I'm going to parse my command line options. I'm going to use something called get_ops. How many of you do any bash shell scripting? How many of you ever heard of get_ops? Okay, a couple of you. So it's very nice. It's a lot nicer than doing this by hand. You know, before I learned about this, I tried to do this stuff by hand, but get_ops is much, much easier. So again, the exact same options as the Python script. S gives you, hey, here's a list of things I want to search for, please. Cluster size, image file name, and offset, if I don't want to start at the beginning of my file system image. I create an array, which is one of those bash extensions. Not every shell has this. And I take my list that was passed in, the comma separated list, and I say, hey, my delimiter, that's what the -d is for, is going to be either a comma or a space. And get rid of that terminating delimiter, please. And I'm going to put all this stuff into find array. And now I'm going to load that up. So here I have another bash extension. I'm using a C style for loop. So if you're not familiar with C, a for loop has an initializer, a loop condition. You know, I keep looping while this is true. And then it also has a modifier or step expression, if you will. So every time you go through this loop, it adds 1 to n. And so what I do is I get this array that I'm going to build out. And I'm going to get rid of this trailing space, which was kind of a pain in the butt, honestly. Made this a little hard. And then I look at that and I say, all right, did they say JPEG or JPG? You know, for those Windows people that can't deal with more than 3 characters and extensions. And then I add things to my array. And these are things I'm going to grep through the results of file to look at. And then I check, you know, did you give me an image file? If you didn't, I'm going to yell at you. And now I'm going to look at the image itself. So I'm going to say, well, how big was that thing? And here's another one of those nice bash extensions. You know, you probably know this. If you want to run something and take the results and put it into something else, you just put it in parentheses, whatever command it is, put a $sign out front. Well, if you do that and you use 2 parentheses, you can do math. So here I'm doing some math and I'm actually calling this command stat to get file stats. And I'm going to say, please give me the size of the file and divide it by 512. Why 512? 512 is the standard size of a sector, right? I'm really sad sometimes when my students, like they're seniors and they don't remember that stuff from their first couple years at the university. And I'll ask them like, okay, standard sector sizes, and they're just like crickets, right? It's like, it's 512. What is that in hex, by the way? More crickets, 200, right? Well, one of the reasons why we like to use hex, right? Hex is beautiful, but you know how it is. A lot of times when people are starting out, they're like, oh, I'm going to use that decimal stuff because I'm used to that. It's like, force yourself to learn the other stuff. Oh, I don't want to do that. That's hard. Okay, so basically this is just going to tell you the file size and sectors. I figure out what's the starting sector. You know, did you give me an offset or not? I'm going to set the cluster size. You know, if you didn't give me one, I'm going to default to 1. And now I'm going to go ahead and read in a chunk. going to read in this sector. So here you go. I'm going to say, what's the info for this file? Well, I'm going to read my chunk. I'm going to use DD. Say my block size is 512. I'm going to bring in one block, please. I'm going to skip ahead. And here's my input file. Any errors, I'm going to send them to that big black hole called dev null, right? I'm going to pipe that sector to file. And I say, hey, file. The file that you're going to look at is actually the standard in. That's what the dash means. And by the way, if you had any errors, please send that to dev null. Okay. And then I'm going to take that and I'm going to pipe it to this tool called awk. And what does awk do? Awk is a great tool for dealing with data that's arranged, let's say, in columns, right? What they call fields. Most people would say words, right? So you have things that are typically separated by white space, but I'm going to tell it my field separator, that's what this dash capital F stands for, is going to be a colon. Because the output from file is going to be something like, file name, colon, and then results. And what I'm going to do from there is I'm just going to print the second field, right? Because I don't want the stuff before the colon. I give this stuff to standard in, right? It's going to have standard in, and it's just going to look ugly, right? So this gets rid of that. Okay, so now what? Now I'm going to say, let me go through and look for things in those results. So I'm going to do something similar here, looking at my results. And, if I get anything, if anything was found. So if the last command, its status was 0, 0 means success, right? Anything that's not 0 means failure. That's standard Unix, Linux stuff, right? Everything returns a status code. So if my search was successful, then I'm going to print a little message saying, hey, look, I found something in this sector. And then I'm going to update my starting sector. All right, super simple. But horribly slow, just like painfully slow. I was searching through a little sample image and it took a few hours. I don't know how long it took to finish because I never let it finish. I got tired of it after a couple hours and I just killed it, right? So the Python script did it in 18 minutes. So from 18 minutes to at least a couple hours doesn't sound so great, right? So what was the problem? Well, I'm pretty sure the biggest problem was using DD. So what's the problem with DD? Hey, open the file, scan to the right place, read a sector, close the file. Do that a couple million times. That's not fast. So I said, okay, let's try something else. Maybe there is some way, the internet has all these smart people, right? They mostly spend time arguing on social media, but there's all these smart people out there. So I'm like, I gotta think like a student. What do students do? You assign them a problem. Google. And they usually end up where? Like Stack Overflow, other places like that. But, it's amazing. I talked to some of my students. I'm like, I remember there's a guy that wrote this word processor for the Apple II series. It was called Apple Writer. Some of you may have seen it. Maybe some of you even ran it. The guy went up to the top of a mountain with miles of extension cord to go write that. It's like today, nobody does that, right? You'd be like, oh, I have to be somewhere I have internet so I can search and find out this stuff. So I'm looking around thinking, surely somebody found a way to do this. No, I see other people asking similar questions. One guy even said, just use Python. Just use Python. Don't even try. Someone else said, oh, well, here I wrote you a simple C program that will do this for you. What the guy was asking. I'm like, all right. So I said, well, maybe we can kind of meet in the middle, right? Maybe I can have mostly a bash script and a bash script that builds a command line for a very small Python script that just does that last little bit, read a sector, etc. Okay. So it looked kind of like this. So here's iteration number 2. And it starts out pretty similar. I'm going to parse my command line. And I'm going to use getOps again. Create my array of stuff. And now I'm going to create an array of things to search for. And I'm going to get really fancy. I'm just going to say search for this or this or this or this, right? Using alternation. And this is another thing that I find kind of funny. Often when I'm teaching regular expressions in a lot of classes, we teach it and we teach it and we teach it because it's kind of an important topic. I get really sad though sometimes when students at least claim and they're like, oh yeah, I never learned this before. I'm like, you took these 2 classes and it's on the standard syllabus for that class. So either someone's not teaching it or you're lying. So anyway, you'll show them how you can do all these things with regular expressions. And then I say, I might have a test question. I want to search for someone named William, right? And how could I find a name that contains somebody who is named William, right? Because William's great. Because William could be William, Will, Bill, Willie, Billy, and there's a lot of different variations. So I'm like, well, come up with a regular expression for this. And what do they come up with? William or Willie or Billy or Will or Bill. Like, well, it does kind of work. So basically I'm cheating here. That's what I'm doing with this regular expression. So I'm saying, okay, I found JPEG, and all of these have that alternation character or alternation. I just made up a word, alternation character, also known as a vertical pipe. And then at the end, I concatenate all this stuff together, and then I just strip it off. I just say, hey, go ahead and do this. So here, what I'm doing is I'm referencing an environment variable. Now in scripting, when you do this, there's kind of the normal way. Like here, I just said $grep string. That's sort of the normal way you do that. And then there's the safe way, where you put the variable name inside curly brackets. Now, when you put things inside curly brackets, there's also some operations you can do to those things. And believe it or not, if you say %, that'll strip off the last character. If you want to strip off the last 2 characters, you just have %, etc. Right? And how do I know this? Because I am God's gift to bash scripting. No, because I know how to use Google. Sometimes I'll have to do things like this, and students will ask me, how did you know that? I'm like, look, I'm going to be honest with you. I don't do this every day. So every 6 months when I have to do something like this, I Google it again and go, oh yeah, that's right. That's how that worked. Okay. And once again, I'm going to check, did you give me a file? get the size. And I'm just going to build a command line for this little Python script called read chunk. And here's read chunk. It has pretty much that little loop. That's about it. So I'm like, oh, okay, well, let's see how that does. Okay, so I ran my original Python script on a 19 gigabyte image for one file type, and it came out about 18 minutes. Hybrid script came out at slightly under 18 minutes. Okay, little progress. Then I said, let me run it for 6 different file types. And the Python script went to 90 minutes. And the hybrid script was still at 17 minutes and change, right? So I'm like, okay, we should just stop, right? No. I'm like, let's try something else, right? I'm at least happier. At first I was like, yeah, this isn't really working out the way I wanted. And I did crazy things, like I even submitted some possible conference talks before I'd really done it. I'm like, might have to change a topic or two. But so I said, well, what if I just use grep? Grep's a great tool. I wasn't in love with this hybrid script idea. And I just built up a regular expression to call grep with. Didn't use the file utility, right? So that was kind of a downside. Instead, I used Gary Kessler's file signatures. If you do forensics, you're probably familiar with Gary Kessler and possibly his file signature page. It's probably one of the most up-to-date file signature pages out there. So I said, let's do that. Right. But there were a couple of problems. Right. So first problem, sometimes I have to search for things that are binary strings. And those are kind of hard to enter. And how do I get that stuff into grep? Right? And the answer is actually pretty simple. If you want to have a hex string, you just put a $sign out front, oops, and then have single quotes, not double quotes, and then you put your stuff in like this, \x, and then your hex value, \x, hex value, etc. In general, by the way, for those of you who are maybe not scripting in Bash all the time, remember there's a difference between double and single quotes. Right? And the difference is this. When you put things in double quotes, the shell interprets them. If you put it in single quotes, it's like, hey, shell, just pass it along. Don't even look at it. Right? So usually if you're dealing with things like regular expressions, I say always single quotes. That way you don't have to think about, hey, will some of these funny characters in my regular expression be interpreted as something by the shell? Single quotes. Don't even think about it. It's kind of like one of my other general rules that I will tell people. If you're searching for anything that's not a literal string, do not use grep, use egrep. Right? Because I don't want to sit and think, because thinking is bad and hard, right? I don't want to sit and think, hey, is this an extended regular expression element or is this a basic regular expression element? Just use egrep, don't have to worry about it. All right, here's a trivia question. This signature I have on the screen here, D0CF11E0, is this file signature for what? Anybody know? He's going to Google it. No. This is an old school Office document. All right. And here's how you can remember it. This is a docfilio. See how it spells out docfile? O. It's Italian. It's a docfilio, right? Okay. Second problem. When you use a tool like grep and you grep a binary file, which all the files that we're talking about will be, it typically just says binary file matches. You're like, well, thank you very much. What matched? Where did it match? Now, grep, as you may know, is a line-oriented tool by default. It says, let me search each line in your text file, and there is no such thing as a line in a binary file. So what does it even print? It prints the line. Well, there is no line, so it doesn't know what to do. So how do you fix that? You can just tell it -- byte offset. That'll say this is where I found it. -- only matching. So only the stuff that matched will be returned. -- text says please treat this thing like a text file, even though it's not. And then I give it my grep string and my image file. Right? Okay, not too hard. Third problem. Decimal numbers. Decimal numbers are ugly. Right? And it's hard to see, is this actually on a sector boundary or not? Right? If everything's in decimal, you're like, is that a multiple of 512? Some of those numbers are really big. It's hard to say, hey, is that what I want or not? So here's the solution. You can convert it to hex using awk again. So now what am I going to do? I am going to add onto this. By the way, this is part of the whole Unix, Linux philosophy. You got a lot of tools that are really good at one thing, and you paste them all together and you do cool stuff, right? So I just took my results and I said, I'm going to pipe that to awk. And once again, I'm going to say -f. This is my separator for fields. It is a colon. And I'm going to use printf, print formatted. It's very similar to C's printf. There's also printf in the shell itself. And I'm going to say match found at offset %x. That says, please print the first thing I give you as a hexadecimal number, colon, %s. The next thing is going to be a string, and add a new line to the end of that. And the first thing is $1. That's the stuff that came before that colon. That was your offset. That's the way that grep's going to put that information out there. $2 is all the other stuff. Okay, this is starting to shape up. But wait, there's still more problems. Some of these search strings aren't very printable. Like our docfilio example is one. If I'm looking for things like a JPEG image, the JPEG image might start with one of three headers, FFD8, FFE0 something something JFIF. I say something something because there's 2 bytes that you don't know what they are, and it's going to vary from file to file. And then there's one that starts out FFD8, FFE8, I think it is. Something, something. And then that one is XIF with a certain capitalization. And then there's one that has a spiff in there. It's not as common, but anyway, the important thing is this stuff's not easily printed. Right? It just looks like garbage on your screen. So you're like, hey, your match was, and you're like, what was that? That's some sort of file, but I might have searched for multiple file types, so I don't really know what it is. So what we do is we use sed. So sed is great for doing substitutions. So I just added, I keep adding to this command here. I said, pipe that to sed. Here's my expression. Please substitute. That's the S command. And then I say /. whenever you find this .filio, please just say office document. That's a lot more human friendly. Similarly, if I see this for the new style office documents, they're XML based, which are zipped with the PK zip algorithm, please just say office XML document or zip file. Okay, getting better. Are we there yet? Of course not. Right. Fifth problem. A lot of false positives, especially with something like a zip file. Zip file is having a signature of PK. It's 2 characters. Gonna get a lot of false positives on that. Okay. So what does PK stand for? Yeah, I think I heard it. Yeah, yeah. So it's the guy that made the algorithm, right? But if you look at a Microsoft executable file, it starts with what? MZ, which is some other guy's initials. We don't have any egotistical people at all in this industry, right? It's like, I'm going to put my initials in there. Right? It's hard to remember that. So I always give people other ways to remember. So like Microsoft executables are Microsoft executables, MZ. PK. What's a PK as it applies to a person? You ever heard the term PK? Preacher kid. What do you know about preacher kids? They're like always repressed and like compressed. See, that's how I remember PK, preacher's kid. Right? And then what happens? Like they go to college and pressure release. You know, what they call that, the pressure cooker effect. Right? Okay. So now I want to eliminate those false positives. Well, this one's probably the easiest one to solve. I'm just going to say egrep on 00 space colon space. So if that offset ended in 00, it's probably not a false positive anymore. All right. And then the next problem. Okay, no. There was no more problems. So here are the results. Check out this runtime. 46 seconds. So I went from 90 minutes to 46 seconds. That's an improvement of 120 times faster. Should I stop there? No. Okay, I kind of stopped there. Now, to be fair, you know, and if you want to, well, I'll just show you real quick. I essentially showed you the script. You know, again, we parse all this stuff, and here it is. It's like this one-liner at the very end of it. I'm just like, run grep, pipe it to this, pipe to that, pipe to that. Just keep piping it so you get what you want, right? Keep making those results smaller and smaller, and maybe reformat them a little bit. So I'm like, yeah, I'm feeling pretty good about that. Now, however, to be fair, I'm not getting quite the level of information I was getting out of my original script, right? Because I went from using file, which does way more than just say, oh, this is a Microsoft Word document. It will tell me this is the author of that document. This is the program that was used to create the document. This is how long the document is, right? If it's a JPEG, it'll tell me what size the JPEG is. If it's a GIF file, it'll tell me which version it is. You know, so it's going to tell me a lot more. So I'm like, okay, since I saved all this time, I'm going to write another little script. I could have implemented this as part of the main script. I just chose not to. And I said, I'm going to use the full benefit of using file. So I went back to DD. I'm like, I'm just going to suck in on one thing, right? Call it a day. I can get away with it. I'm not doing this a million times anymore. So I said, all right, let's do this. DD, block size 512, standard sector. Count 4K. I'm like, 4K sectors probably ought to be able to tell me about this file. Might be larger than the actual file, but it's going to work, right? File is going to do a really good job about telling me about this file. I'm going to skip ahead to whatever offset you gave me divided by 512. Again, I'm using that little trick. I'm doing math in the shell. My input file is going to be the second argument you gave me. Any errors go to the big black hole known as dev null. I'm going to pipe that to file dash, and errors go to dev null again. And here's an example of, it's kind of hard to read in here, but anyway, this was looking at a file that turns out, it says, I'll just read it to you. Composite document file, version 2 document, little indent, OS Windows version 5, and creating application, Microsoft installer, subject, ENGNSE, ship, author, Microsoft Corporation. Here's keywords in it, comments, and it's 30 pages, it's a template, and all of this. Number of words, what does it say? Number of words, 1. I don't know if I believe that, but it's 30 pages, but there's only 1 word in it. Maybe that's off my screen here, but anyway, so it's telling me all of this stuff. So I'm like, I still have that. Even if I took the results from the first script and I piped it to this script, I would still get it to run in, I don't know, maybe it would take a minute. So I'd only be 100 times faster instead of 120, but still, I think pretty good. Right. All right, so that's pretty much it. Any questions? Everyone's tired. It's the second to last talk slot. So thanks for sticking with me to the end here. No questions? Oh, just one quick thing I will mention though, since I have a couple of minutes. If you didn't know, I heard there's a really cool conference that happens at the end of March in Bloomsburg, Pennsylvania called BloomCon. And if you want to know more about that, ask me later. But we actually put that on every year, and more than welcome to come up and see us for that, and I'll tell you more about that later. So thanks for listening.
This talk was a part of our 2022 Secure West Virginia Lucky 13 conference. If you would like more information about this talk or our speaker, check the description below. And if you enjoyed the content, consider liking and sharing this video. For more information on Secure West Virginia, or you want to stay updated with the latest upcoming events, follow us on Twitter at SecureWVCon or visit our website securewv.org. We would also like to thank our 2022 sponsors for being a huge part of Lucky 13's success.